So again, the same idea with match problem 5. Given our function, we want to find critical values, determine where our function's increasing or decreasing. So we'd start off by taking the derivative of our function, which will be 5 over x minus 1. So now what we want to do is actually add these together, which we can do by getting a common denominator. So keep in mind any number can be written as a fraction over 1. So our common denominator here is going to be x. So we'd multiply both the numerator and denominator by x to get 5 over x minus x over x, which will give us 5 minus x over x. So now we have two different types of critical values we need to investigate. The first is where this function itself could be equal to 0. So that's only going to happen if the numerator is equal to 0. So 5 minus x will be equal to 0 only whenever x equals 5. So that's one critical value to consider. The other is if we get a 0 in the denominator. So x is going to be equal to 0 in only one case, whenever x is equal to 0. So we have a critical value where our derivative is equal to 0 and a critical value where our derivative is undefined. So we have two critical values to consider, and we want to determine what's happening on either side of those. Now, one thing we can go ahead and take advantage here is that our original function is going to be undefined. Since we have the natural log of x, that's going to be undefined for any values that are 0 or less. So we can actually just scrap all those negative values. This function will be undefined for any negative values, so we don't even have to worry about that. What we do need to do then is choose test points on either side of 5, so we can look at 1 and 6 as two possible options here. So evaluating our first derivative function at 1, that's going to give us 4. So our function is increasing. And evaluating the derivative at 6 is going to give us negative 1/6. So our function is decreasing. So in this case, our function does change from increasing to decreasing. So we could say that our function is increasing on 0 to 5. And again, we're not worrying about any values less than 0 because the original function would be undefined there because of the natural log function. And it's going to be decreasing on 5 to infinity. Now, what this question doesn't ask us to do is identify any maximums or minimums, but we could go ahead and throw that in there as well. So we know that we have a function that's increasing and then changes to decreasing. So this value is going to be our local maximum, and that's occurring at x equals 5. So we could say that x equals 5 is a local maximum. Again, the question's not asking us for this, but the homework is going to be doing that. We've already introduced the theory for it. So we can go ahead and identify that point as an extremum, in this case specifically a local maximum.